Hi and Happy New Year! A lot of people ask me to check these power saver devices that are supposed to save you tons of money by reducing power usage at home. What these things claim to do is a power factor correction when plugged in, and if you search about them you'll see tons of videos talking about what a piece of garbage these are. But wait until you hear my opinion about it. That is, if YouTube is not blocked in your country. That's why this video is sponsored by ExpressVPN. Not only it greatly secures your internet experience against all sorts of threats, it allows you to access websites and content that are blocked in your country. Actually, I traveled to China back in March 2018 and I was cut off from my YouTube and social media. Coincidentally, I installed ExpressVPN on my phone and laptop, turned it on, and BAM! I looped around the filters imposed by the government of people. But wait! Follow this link, get 3 months free on a 1-year package for less than $7 a month, and afterwards see if you still feel like letting your identity get stolen. Anyway, I bought my own power saver from Amazon. This one says Intelligent Energy Saver. The result is the best. So there must be some smarts in it. Let's cut it open. Well, there is an LED and some resistors in here to indicate that you have plugged it in case you're deaf and can't see that you have plugged this giant break into the wall. And then there is this potted black box that I suppose the brains are in here. Let's cut it open. This black box is a single component, a high voltage capacitor with a value of around 2.1 microfarad. There is no brain in this. They lied. All of them lied. Those son of a... Okay, wait. So this is the same garbage as all of them, just a capacitor placed directly on the power lines. But capacitors are in fact used to improve power factor. See, as I explained before, there are two types of AC power. One of them is real or active power, where the load consumes the power and does the work, and the voltage and current are in phase. It is like walking. The force you apply that moves you forward does the work for you. The other type is reactive power, that is due to capacitive or inductive loads and doesn't do any work at home because the net active power draw by these components is zero. And depending on if the load is more inductive or capacitive, the current lags or leads the voltage by 90 degrees. Like when you walk, you have to lift your leg and body up and down. That force doesn't move you forward but results in inefficiency and waste of power at the source. And the combination of active and reactive power is called apparent power. And the power factor is just the active power divided by apparent power. We want the power factor to be 1 so that all the power transmitted is used. The downside of the reactive power is that although it doesn't do any work, it results in current flow through the power lines, increasing the power losses. It is significantly higher in factories and industries that use tons of AC motors and transformers. That's why most reactive loads are inductive, with current lagging behind the voltage. And we know that in capacitors, the current is leading the voltage. So if we add a capacitor parallel to the inductive load, with the peak current equal to the inductor current, 180 degrees out of phase, they add up and cancel each other. Power factor fixed. For example, most fans with AC motors don't have a capacitor in them to correct the power factor. It is drawing 0.7 amps and I have a 10 microfarad capacitor. Watch the current carefully as I connect the capacitor. The capacitors used on power lines are rated for high voltage and are not polarized. Anyway, at home, the reactive power is not doing anything for me. I shouldn't have to pay for it. In fact, let me check with BC Hydro, our local power supplier. I have a question about my power factor.
Cutting out, I can't hear you. Hello?
Depending on the power factor, you charge differently. Is that for business customers only?
Yeah, power factor is a surcharge charged to business customers whose power drops below 90%.
So it doesn't matter if my power factor is bad at home. I mean, I can make it bad. For example, if I connect a motor that draws a lot of power,
that's going to increase your consumption, but it'll have nothing to do with power factor.
It does. Yeah, it might be a little bit too technical, what I'm trying to ask.
I can transfer you to another department.
Would you know at home, do I pay for apparent power or for real power?
For what kind of power? Apparent. Spell that word.
Get the merch while you're at it.
matey. You're being billed real power.
Only.
At the meter.
Anyway, residential homes in Canada and US and probably anywhere in the world only pay for real power, not reactive power. Only industries that use a lot of reactive power pay some surcharge for it. There you go, right off the bat it's useless. It's trying to fix something that I'm not paying for. I doubt it, but let's assume some of you live in a system that charges reactive power. Does this help? The whole point of this would be to drop the current draw from the power lines. If I plug it in, it draws around 95, say 100 milliamp of current, which is 12 volt amp of reactive power. So alone, or when the device is off, this actually makes the situation worse. Let's cut the stupid LED out to reduce the current draw a bit. Yeah, I guess the LED wasn't drawing much. So that's it. 100 milliamp is the The capacitor was charged. I guess that was the point of the LED. It was discharging the capacitor when it was not plugged in. Well, good news everyone! Even if this is a piece of junk, you can remove the LED circuit and turn it into a novelty shocker. Just plug it in, and if you unplug it when the AC cycle is at high voltage, you can run around and shock your friends and family with it. Let me use my microwave transformer. If I turn it on and measure current, it is drawing around 4 amps at no load, which is around 480 volt amp of reactive power. It's a lot. Now if I connect my power saver, the current drops by around 100 milliamps. So it does help in an insignificant way. The maximum current reduction would be the 100 milliamp of the capacitor. But we are not paying for that 100 milliamp to start with. Let me open our fuse box to measure our home current. There are two phases coming to our home, with black one being the main one, which is providing 2.5 amps at the moment. Let's see if connecting this makes any difference. There, the current dropped by 0.1 amps. And you know what the capacitor is compensating for? It's our washroom fan, which is an AC motor running. Let's turn it off. Now with the fan off, I'm drawing around 1.3 amps, and if I connect this, it actually makes it a little bit worse. What if I force the fridge compressor to run? With the fridge running, I'm drawing 2.6 amps, and if I connect this, nothing. See, that's the thing. For the big AC motors that provide a constant output, such a capacitor is usually included in their design to help with the power factor. So adding another small one like this doesn't make a big difference. Now let me turn on the actual microwave. Holy shit! It's like drawing around 14 amps and there's nothing in it. Let me put a cup of water in it and see how much it draws. Wow, the microwave is such an inefficient piece of junk. Well, maybe in an empty microwave, most of the power was reactive, and when I put a cup of water in it, some of it converted into active power. But in any case, adding this tiny capacitor doesn't make any difference in the big scheme of things. Maybe less than 0.5%. And I wasn't paying for that current anyway. At home, most electricity is used by light bulbs or electric heaters or electric oven or switch mode transformers, all of which this thing doesn't help at all. The most significant improvement you could see using this would be on small inductive loads like this old-fashioned transformer. Right now it's drawing around 20 milliamps, and if I connect this together, always use solid connections. See, the inductor here is drawing around 29 milliamps, and if I connect the capacitor, the current goes to 70 milliamps, which is funny. It is more than the inductor current, but less than the capacitor current, which means here the inductor is helping to improve the performance of the stupid power saver. Another good example is this AC motor I took from a microwave oven. And if you look at the current, it draws around 190 milliamps. And if I connect the capacitor, the current drops to around 130 milliamps. So it helps a bit in some cases if you ignore the fact that after I turn off the motor, the capacitor continues to draw current from the lines. And I wasn't paying for that extra current anyway. Why do they sell shit on the market? It's garbage. Oh wait, I could still use it as a novelty shocker. Well, you know what's very good? ExpressVPN. It is a very fast service that protects your privacy because your data will be encrypted, so hackers and hookers, crooks, no one can track your online activity. You want to watch this video? Too bad it's not available in your country. But you go to ExpressVPN, choose your location in US, turn it on, and bam, refresh, and you can watch your video. So make sure to check ExpressVPN/ElectroBOOM and get 3 months free on a 1-year package and take back your lost privacy. Do it! And thank you for watching.